Anybody remember from last year where you would find the vertex on a parabola? What do we mean when we say, where's the vertex? Maybe if I drew one, you might know. Go ahead, Hayden. Okay, so where would it be on this one? Okay, so the vertex is sitting right here. Or if the parabola was reflected upside down, the vertex would be sitting up here. Okay, so that's called the vertex. The axis for a parabola goes right through the center down to the vertex, or right from the vertex down through the center. Okay, that is called the axis. And you can tell where the vertex and the axis are going to be just by looking from what we learned from chapter 1. All right, so example, find the vertex and axis. Without graphing. Okay, so let me give you your starter question. Find the vertex and the axis without graphing. So here's the question. -2 x minus 3 squared plus 5. Okay, if that's the equation, which of the two parabola options is it? Is it the one that's right side up, or is it the one that's upside down? Upside down, okay. How do you know it's upside down? Because of the negative reflection. All right, so now we need to know where the vertex would be. Because the vertex is not going to be on the origin anymore. This thing has been flipped upside down. Besides being flipped upside down, what else has happened to this parabola? What does that mean right there? Right 3. And then what about this part? Up 5. That's the location of the vertex. And so we would say that the vertex is sitting on the coordinate 3, positive 5. So it's gone to the right 3 and it's gone up 5, and that's where the vertex is. So I didn't have to graph it, but I could picture what's happening, that it moved to the right 3 and up 5. The axis has to go right through the center of the vertex. And if you imagined on your axis right here, if all of these were little coordinate points all the way down, what would be the same all the way down if I made those all points? What would be the same all the way as I go down there? Starting at 3, 5, but the one right below it would be at 3 what? 3, 4, and the one below that would be at 3, 3, and then 3, 2, 3, 1. So what's staying the same? The x is staying the same. And so we call the axis x equals 3. It's an imaginary line that goes right down the center where all the coordinates of x are 3. That's how you call the axis. It's just the x value. And you do that without graphing. Okay, but now I got to throw a little twist at you. Okay, now find the vertex and axis of this question. Okay, so the next one is g of x equals 3x squared plus 5x minus 8. All right, what can I tell about this parabola? Is it going to be an upside down or a right side up parabola? This one's right side up. I can tell that pretty easily because of the number 3. What can't I tell about this parabola? I mean, compared to what I could tell last time? I can't tell where the vertex is because I can't tell, did it go right or did it go left? Did it go up or did it go down? Some people look at the -8 and they think, oh, it went down. But that might not be true. Or they think at the 5, that might not be true either. So that's the thing we have to figure out today. Okay, did it go right or left? Did it go up or down? The answer to these two questions are two new variables that we haven't talked about before. It's the variable h and the variable k. H will tell us if this thing went right or left. K will tell us if it went up or down. And there's formulas for that. The formula for h is the formula negative b all over 2a, or over 2a. The negative b and the whole thing over 2a. Where have you heard the over 2a before? The quadratic formula is exactly, this is part of the quadratic formula. X equals negative b plus or minus squared, all over 2a. It's only the negative b and over 2a part. That's going to tell you what the h is. It'll tell you if this went left or right. So let's do it. Let's work it out for this one. Which number represents the b position? The 5. So this is going to be negative 5 over 2 times a, which is 3. So this is negative 5/6, which means it went left. Negative means it ended up going to the left. Okay, the k value is going to tell us if it went up or down. So how do we get k? There's not a special formula for k. To get k, you're going to plug in h. You're going to plug it into the parabola equation. So you're going to take whatever you got for h, and you're going to plug it back in. So we'll have 3 parentheses, negative 5 over 6. Always use parentheses so that you don't mess up the negative. Plus 5 parentheses, negative 5 over 6, minus 8. Okay, could you use your calculators for a moment, please? Grab them out, put parentheses around those, and type it in and tell me what we get in fraction form. Okay. All right, negative 121 over 12. That means it went down. So our parabola starts out facing up because of the 3. It's stretched by 3. It went to the left and it went down. So let's write an equation for a parabola as we normally know it. I want you to create me a parabola that has a stretch of 3, just like the original equation. It goes to the left 5/6. How do we write that based on what we learned last chapter? X plus or minus? Plus for the left, 5/6 quantity squared, and I want it to go down 121 over 12. That is called the vertex form of a parabola. When you write it in a form where the vertex, the h and the k, the left and the right values and the up and down values are very clear and evident along with the stretch. Okay, this is called vertex form. And so now we know that the vertex should be sitting on negative 5/6, negative 121 over 12. That's where the vertex will sit. And the axis should be going directly through the center of that vertex. And so the axis should be equal to x equals negative 5/6. So you have your vertex and your axis. So overall, we want to summarize that, and we want to say what vertex form is. Vertex form is where you write y equals a for the stretch, x minus the h value squared plus the k value. That is called vertex form when you write it with parentheses. So what I started out with was not vertex form, but what I want to write is vertex form. So we'll put a box around that, and that's kind of like the important thing for today. You know, if I tell you what's the form for a line, you say y equals mx plus b. What's the vertex form for a parabola? And you've got this equation as your vertex form. So we're going to practice with this for the rest of the day. finding h, finding k, finding the left, right, the up, down, not necessarily the graphing part of it, but just the equations part of it. All right, so our next one. Find the vertex and the axis. For the equation f of x equals 6x minus 3x squared minus 5. Find the vertex, find the axis. Right away, I noticed something's wrong with this equation. Did that stand out to you at all? What'd you notice, Katie? Okay, could you arrange it properly for me? That's the first thing we need to do. Sure.
Okay, so it'll be -3x.
Okay. Now, right away that she's got it in the right order. What can you tell about this parabola right off the bat? It's upside down, okay? It's upside down. So we think about all of the NSRT stuff that we did before. Now it's in the normal order, so we've got that right. Okay, upside down is the reflection because of the negative. What else can I tell? It does have a stretch. How much?
3.
Okay, so the stretch is 3. It's the translation that we don't know. The translation is what's H, what's K? H will tell us the left, right. K will tell us the up, down. But right now we can't tell what that is until we do the math. Negative b over 2a. So now that we've got it in the right order, let's figure out what the left and the right and the up and the down are going to be. So h is going to be negative b over 2a. In the new order, negative b is negative 6. And 2a is 2 times negative 3. So that'll be negative 6 over negative 6, which turns out to be positive 1. Positive 1 for h means I'm going to the right. How do I find the k value? Okay, plug it back in where? Okay, to the original equation. So k equals negative 3 with parentheses 1 plugged in, plus 6 with parentheses 1 minus 5. That's negative 3 plus 6 minus 5. That all works out to be negative 2, which is down. So now I can tell what my vertex is. NSRT, the T for translation. I can tell that my vertex is 1 to the right and negative 2 down. That is my vertex. My axis is x equals 1. It's just the x equals the part of the vertex, the h part. And then the correct form we would put it in would be y equals. And now we're going to put it all together. We're going to put the stretch in there, we're going to put the reflection in there, and we're going to put the position of the vertex all together in one vertex form. So the upside down reflection needs to lead it off. Stretch is going to be of 3. The vertex was 1 to the right, so in parentheses I write x minus 1. I make sure to include a square, otherwise it's not a parabola. And then 2 down. And now we've written it, the vertex, the axis, and we've put it in vertex form. So you're just changing the equation into vertex form by answering really basically the NSRT questions. Any questions so far? Let's try something similar with a little bit of a twist. All right, find the axis and stretch for the parabola that has the following vertex. Okay, and the vertex is 2, -3. Whoa. And a second point at -1, -6. Find the axis and the stretch. So this time, last couple times we've always known what the stretch was. This time we want to find the stretch. That's the A value. So I just feel like we want to go back to what we've got. Okay, and we start with a normal parabola, but here now we know the t first. Instead of figuring out the t last, this time we know the t first. And we know the t is left 1, down 6. Left 1, down 6. So we're going to use a partial equation. Y equals A. I need to show left 1, excuse me. Nope. That was the wrong point. I did it for the other point, sorry. I got to read the vertex. The vertex is 2, -3. Okay, we want right, sorry about that. Good thing I stopped myself. Right 2, down 3. Okay, so we want to show right 2, down 3. So right 2 is x minus 2, down 3 is minus 3. What do I do with the second point that was given to me? Well, the second point is not the vertex, but it's x and it's y. So that second point is going to get plugged into the x and the y. I'm going to plug those right in. That's going to help me figure out what the stretch is, because this parabola has to start at the vertex and then stretch somehow and get to that other point. So now I'm going to put in -6 for y. A is the stretch. I'm going to plug in -1 for x. And now I'm going to solve that. When you solve something, you always work with please excuse my dear Aunt Sally. So parentheses first. And so the parentheses give me -3. Then I do the exponent. And -3 squared should not be -9, but it should be +9. Make sure that you square things correctly. So that's please excuse. Then my dear Aunt Sally, now we start doing the math on both sides. We add 3 to both sides. So that's going to give me -3 equals A times 9. That's from adding 3. And then we divide by 9. And A turns out to be -1/3. So not only do I know the stretch is 1/3, but I also know it's negative, which means I have the reflection. So I can go back, and I know that the stretch turned out to be 1/3, and the reflection is going to be upside down. All because it turned out to be a -1/3. So now I want to write my full final answer. I want to write an equation that says y equals, and then I want to put everything in the right position. I want to show that it's an upside down reflection, so that's going to be first. It has a 1/3. It has to go to the right 2, squared to be a parabola, and down 3. That is called the vertex form. The only thing I haven't done yet is the axis. The axis is going to have to go right through the vertex. And so I look at my vertex right here. Here's my vertex, circle around it. And so then the axis is going to be x equals 2. That's usually a pretty easy one to do because you just look at the vertex. So some of that was a little bit tricky, so I want to show you one more just like it so that you can see it twice. All right, so final answer was in vertex form. Okay, last one. Write the vertex form for a parabola with point being 1, 5 and vertex being -1, -3. Okay, write the vertex form for a parabola. And I didn't tell you to find the stretch, but you're going to have to find the stretch because you can't write the vertex form unless you figure out what the stretch is. So you think, all right, N, S, R, T. N is a normal parabola. The T for the translation is the vertex. My vertex is left 1, down 3. I got that from the vertex. So I can start my equation knowing that much. Y equals A, which I don't know yet. Left 1 will be x plus 1 squared down 3. So normal parabola, left 1 down 3. Now I take my point, which is the extra number that I have, and those values are going to get dropped into x and into y. So this will become 5 for y, 1 for x, and then I use please excuse my dear Aunt Sally to solve. The only thing I don't know is the stretch. So notice that the problem doesn't say, hey dummy, come out and find a stretch. You got to know that, but that's part of the process. So we're going to do parentheses first. 2 squared. 2 squared is 4, so this will be a times 4. Add 3 to both sides. That'll give me 8 equals a times 4, and then divide by 4, so a turns out to be 2. Since that's a positive number, there is no reflection, so we can go back up to our stretch. Our stretch turned out to be 2, and the reflection is none, because it was a positive number. So the final answer for this is going to be the equation that starts with y equals, the stretch is 2, the vertex is 1 to the left, and also 3 down. And that is the final answer in vertex form that satisfies the original question. But sometimes people get confused because they forget they have to find the A. The A is part of it. Notice that what is not in the final answer is the 0.15. The 0.15 doesn't have any part of the final answer. It's just like a transitory part to help you figure out the A that you need, but it doesn't actually reveal itself anywhere in the final answer. Okay, any questions about that? That's the beginning of chapter 2.